Deutsche Bank has reported that ICT has entered the post-PC era. And that poses a question, where is the business? To hear part of the answers, let's welcome Mr. Phil Carmack, Senior Vice President and CEO in Mobile Business Unit of NVIDIA, speaking on how graphics will be more important than ever in the post-PC revolution. Ladies and gentlemen, please welcome Mr. Carmack.
Thank you. It's a privilege to be here today. I love Computex. It's been around 31 years, I guess, now. That's before I was even in the industry, but not much before. And I've been coming here for at least 15 years off and on. And I love the energy and excitement that's around it because there's a true appreciation for computing and all of the ways that it improves our lives here. My name is Phil Carmack. I'm the head of the mobile business unit at NVIDIA. I'm actually the founder of that business unit. Started it about 8 years ago inside of NVIDIA. The inventor of most of the core technology that was originally put into the Tegra product line. I've also been at NVIDIA for about 11 years now, and I've had the privilege of, beyond that, watching all 4 of the major computing revolutions that have happened. From my first job out of college was working on mainframes at a company called Amdahl. So I've worked on mainframes, super workstations, PCs, and now mobile processors. And I can truly say that these revolutions have dramatically changed our lives, and it's happened in my lifetime. Let's see if I can press the right button. There we go. What I'd like to talk to you about today is cloud graphics. And I'd like to start by talking a little bit about our latest graphics processors at NVIDIA. The internal name we used for this series of products is called Kepler. And the breakthroughs in Kepler have a lot to do with efficiency and virtualization. Now, Kepler is by far the most efficient, highest performing graphics processor ever built by NVIDIA in our 20-year history. And that has allowed us to do some very unique things that I'll talk to you about in a few minutes. At our technology conference called GPU Technology Conference a month ago, we announced 2 new products that are based on Kepler that have begun shipping, the GTX 690 and the GTX 680. These are the 2 highest performing processors we've ever built. They're selling well, and they're creating an incredible amount of interactive experience for our enthusiasts. As you also may be aware, these graphics processors are not only used for gaming and interactive 3D graphics visualization, but they're also used for supercomputing. And I'll talk a little bit more about that in a minute. So as you can see, the 2 big areas where Kepler is being used first is graphics processors. These are just processors that go into your PC. And computing, or the high-performance computing industry. And many of the highest performance supercomputers in the high-performance computing industry have GPUs in them. And because of Kepler's efficiency, a lot more computing is able to be realized in the same amount of space. Another interesting phenomenon that is leveraged by this new form of computing is this concept of bring your own device. Now, when I first came out into the industry, we worked on mainframes. We did computer design and other types of things with a terminal connected to a mainframe in another room. And we used characters and typed them in, and that's how we got our work done. Today, young people that come into the industry that are working Facebook or Google or NVIDIA or any other high-powered technology company come with a host of digital life that already surrounds them. They come with a host of computing capabilities and interests as well. And in many cases, they bring their own devices as well. And one of the problems is if you are in the IT industry, you know how hard it is to take somebody's mobile phone or tablet or PC and bring it into the security and safety of your professional network. So this has created an additional constraint, and I'm going to talk about some solutions we have now that make it possible for you to bring the device you're used to in order to have the experiences you're used to or experiences that you've created out there. Now, of course, if you look today in terms of cloud computing, you'll find that there are many people already using native devices over a virtualized world in order to get their job done. You have task workers. Those are people who tend to use a single application. Maybe they're in a call center, or they're in a support role, or maybe they work as an online order taker, or whatever it is. Those people generally have a relatively low bandwidth requirement between them and the compute farm. And they also have a relatively simple set of applications. And as a result of that, they can use a relatively simple terminal. Maybe it's a PC, maybe it's something simpler than a PC. The next step up from task managers, or task workers, is knowledge workers. Now, knowledge workers have a little bit more sophisticated set of tools they use. They might use Microsoft Office or other forms of professional SAP, other forms of professional tools. And they have a higher requirement on the system. They require more interactivity with the system. They require online transaction processing. They require use of certain specific types of applications like PowerPoint or Excel or Photoshop or, like I said, SAP. Now, those users are typically served by a virtualization environment like Citrix or something like that. And what is the benefit of providing Citrix or some other form of virtualized environment for your end users when you're in an enterprise? Well, there's a number of benefits, but the first and most important one is convenience. So if I've created a set of applications and parameters that I've set up for my own usage, or personalities, if you will, if I have a virtualized environment, I can go to any device. I can change devices. My device can break and I can get a new one. Or when the latest and greatest MacBook Air comes out, I can buy that and use it because my entire personality for computing is already out there on the cloud. Furthermore, my IT department manages a centralized resource and simply has to deploy clients out to the users. And the applications are hence virtually served. And this is part of the progression from the PC world into the post-PC world. Essentially, you have a virtualized PC. It's the entire experience of a PC, but you don't have a PC sitting in front of you. That's essentially what we have today with knowledge workers using virtualization. Now, the next step up from that is a power user. The power user would tend to have much more complex and sophisticated and powerful applications like imaging or other forms of development that would require a dedicated PC. Now, for those environments, typically to fully virtualize that would require a very high bandwidth or a very large amount of compute available in the farm. And then there's the extreme high end of that, and that's designers, people who are doing, today they're buying an NVIDIA Quadro for doing design, 3D graphics design with solid models or doing film and animation. And those require extremely high performance and extremely high interactivity in order to be achieved. We're starting to supply those types of things with our new environment. And that is being delivered by our new NVIDIA cloud computing processors. Kepler is our first processor that's fully optimized to be a cloud computing engine. It allows you to have all the benefits of interactive client-side high-performance computing or visualization while putting it into the cloud. This is a non-trivial thing. If you look today, we've had for a while cloud storage, cloud computing, where you could do things like Hadoop or other forms of large-scale computing on a Amazon or other compute server farm. We've even have GPU-based computing for scientific applications on supercomputing. We've had video streaming, which has been available on the cloud. So we've had almost every form of application, including forms of entertainment and professional use, available on the cloud. The one thing that has not arrived on the cloud successfully up until now has been the full GPU experience. GPU experience has a couple of constraints that make it very difficult. The amount of information that's being presented to you when you are operating a GPU is extremely high, and therefore the amount of bandwidth required to connect is very high. But even more important than that is the fact that the latency has to be extremely low. And I'll go into the reasons for that in just a moment. But we've solved those things with our new cloud computing processors, and this is what makes the opportunity for us to now have all of the major activities available to us on the cloud, have the convenience and a bunch of other features that are important that the cloud gives us without compromising the experience. And this is the reason why people today build their own PCs, is because they don't want to compromise their experience. This is a way to allow that experience without having to wait till you built your own PC. Now, when I say Kepler is the world's first virtual GPU, if you would take a look at this diagram, I'd like to explain to you. The green portion of this diagram is the generic GPU. I've already told you that Kepler is by far the world's most efficient GPU ever built. And in today's world, in order to achieve the highest performance, you need the highest efficiency, because whatever system you're going into will have limits in terms of how much power can go into it. If I'm building a compute farm, the limit is how much power is available from the central grid to drive my building. And that drives the air conditioning and the power into all the racks. If I'm in a PC, the total power coming into my PC power supply. If I'm in a mobile device like this, it's the total amount of battery life that I'm able to achieve when I try to do all the things I'm doing. And therefore, efficiency is critical. So the first building block of being able to create cloud graphics, or cloud GPU, was to have the most efficient GPU on the planet. Now, the second thing about it was to be able to solve the latency issue. And the latency issue is a very real problem. When I'm watching a movie, if there's 1 or 2 or 3 seconds of latency from the time I hit play to the time the movie starts playing, that's no problem. When I'm playing a video game, the amount of time, the amount of latency allowed for me to be able to perform an action and then have a response from the system is measured in milliseconds, not seconds. And so we had to solve the latency problems. There's dedicated hardware built into Kepler that allows this ultra-low latency capabilities, both in terms of the remote display and in terms of getting data back and forth. And there's direct hardware support for this. The other big thing that's required is virtualization, because GPUs are generally dedicated, hardwired into the system processors. Virtualizing them has been difficult until today. So we've now created part of this diagram that you see in the other colors is the virtualization logic that allows the GPU to be presented directly to a software stack as if it were a hardware GPU, just like other forms of virtualization. And this is for the first time that it's been possible to remotely access the hardware, and the hardware itself is aware of the virtualization and able to take care of it for you. Many important breakthroughs went into Kepler, and it was years in the making and a $1 billion investment that got us here. And what we would like to see as a result of all this is that all of those different kinds of devices that you might be interested in having, whether it's a multi-screen, large, interactive graphics device or a cell phone this size, all of these devices are able to pull up that your entire experience that you would have created if you were back in the office or back in front of your special gamer's rig or back in front of the supercomputer at Lawrence Livermore Labs. And so what happens is we've gone from, we often talk about the mobile industry as the always-on industry, because when I pull out my cell phone, it's on. It's immediately on. I don't have to wait for it. When I open my PC, sometimes I do have to wait a little while, but when I pull on a cell phone, I'm connected already, and the response is there. It's ready to work with me the moment I pull it out. Well, when we talk about cloud computing, I like to think of it as your computing environment is not only always on, it's always there. And having your computing environment always there may not mean a lot to some people, but those who are professionals or those who are serious computing enthusiasts, having that same experience anywhere would be wonderful, because they don't have to go into their basement where they have their game console set up, or they don't have to go into the office where they have high-end graphics visualization workstation set up. They can do that on their local device and have all the power and capability and personality of their computing environment available to them. And fortunately for us, because of the computing part of our GPU business, the Tesla business, we've already established that the form factor of what needs to be put out into the cloud, the server farm, in order to be able to do cloud activities. So today, if this is a rack-based server box, right there is the GPUs that go in. The form factor, actual size, the connectors, the power, all the different features that are required in order to be able to have GPUs integrated into this box already exist because of the Tesla business. Now we're able to use that same footprint to take a full GPU accelerated into the cloud, and we call that VGX, Virtual Graphics Acceleration. And as a matter of fact, every major OEM already has racks that are set up to be able to take virtualized GPUs. So the VGX phenomenon, just announced, is already possible to produce and to replicate in very large computing farms as necessary. Now, VGX is actually made up of several different key components. Number one is we had to create this NVIDIA VGX board. We had to create hardware that was capable of being virtualized, so you could have true hardware acceleration in a virtualized environment. Number two, we had to create the NVIDIA VGX GPU hypervisor. Now, this is just like any other hypervisor, except that it's hooking up to something that's never been virtualized very well before. And so the hypervisor part of it is a software stack that's closely tied to the hardware and software architecture performing this. Once you have this hypervisor done, which we deliver, something like Citrix or other forms of virtualization environments can then sit on top of that. Now, on top of Citrix, you will have various different personalities that might be needed. So now I can buy a virtual workstation, and there's various different things I might need. NVS is a product that we use for non-3D graphics forms of professional systems. So somebody who maybe works in the financial industry and they need to be able to do some of the unique things with spreading large amounts of windows over 4 or 5 or 6 displays, and they normally would buy a workstation to do that. Now they can virtualize that. Somebody who's doing design of a new automobile, say the new Tesla or some other new car, they also would be able to buy a virtual workstation that they could then play on their local display, or any other standard NVIDIA user selectable machine. Essentially, the whole concept of your workstation or your work environment becomes virtualized. The use, the monetization, and the maintenance of it. And as a result, this is what we expect to see. There's racks in the background that are performing the GPU serving in a virtual way, and then there's local devices, whether they're bring your own device, like people who now have their own devices they want to bring in, whether you're on the road and you want to bring up that solid model that previously could only run on your $100,000 workstation, or whether you're sitting in your office and you have a screen that's hooked up to your enterprise network. All of those things are possible. Well, the next big thing, of course, is to take that and bring cloud GPU computing to gaming. As many of you may be aware, there are already forms of cloud gaming available, things like Gaikai and other forms of cloud gaming. And one of the reasons why do people need to do cloud gaming? Well, there's a couple big reasons. Number one, you can play it anywhere. It's always there, as I said before. So if I go over to my friend's house and my friend doesn't have the same gaming setup that I have, I can still play the games and show them how I play. The other big thing is that it's piracy resilient. The game developers spend a lot of money, and as some of you may be aware, the launch of a new game can often be 5 times as large as in the first week, 5 times as much revenue as the total revenue you might get from an international blockbuster movie. In many cases, the amount of revenue from a new game, can be close to $1 billion. But the game developers may invest $100 million or more into this development, and they care a lot about piracy. And one of the things they like about virtual or cloud gaming is that it's piracy resilient. However, there are problems with cloud gaming, and that is the latency. So what do we do about that? Well, if you look at the demand side for cloud gaming, I would say it's very high. And I'm just using this as a proxy. A few years ago, the size of the online video distribution business was a fraction of the size of the disk-based video business. Just a few years, maybe 4 or 5 years ago. Now that is completely flip-flopped, so it's almost almost 5 times as large in terms of video purchases online compared to hard media purchases of video. Why is that? Is the video better? Is online video better? Anyone know the answer to that? Is online video better than a Blu-ray video? I see someone shaking his head. No, it's not. Why? Why do people do it then? There's only one reason: convenience, right? And convenience tends to drive everything in technology. We're trying to make life more convenient. Well, so there's every evidence that if people could have the convenience without sacrificing quality too much, they would go with cloud. They would go online, just like people are doing now with video. But there's some problems. If you look at a game console today, on average, you would see about 166 milliseconds of latency from the time I press a button to the time something happens on the screen. And so gamers would expect that. On a gamer rig, they might even expect slightly better than that on a PC. But let's just say that a game console is a good enough proxy for game enthusiasts. Now, that 166 milliseconds, what does it represent? Well, the average human response time is about 200 milliseconds, 0.2 seconds. So if someone throws something at you, you respond to try to block it in about 0.2 of a second. Or if you see an emergency happening, you move to start hitting the brake in about 0.2 of a second, if you're an average human being. Certainly you wouldn't want to be worse than that, right? Because it would make the experience difficult for the real high-performance gaming. Pro athletes actually have as much as fast as a 50 millisecond response time to external stimulus. So extremely fast reactions. That's why when someone hits a baseball in American baseball, and there's only 400 milliseconds from the time the ball leaves the pitcher's hand till it's in the catcher's mitt, they have time to not only watch that ball, react to it, swing the bat, manipulate the bat so it actually hits the ball in a fraction of that time. So this is very important, and being much slower than what a game console is probably not acceptable for the highest forms of gaming. Well, the first generation of cloud gaming simply didn't achieve that objective. It took more like almost 300 milliseconds to react. Now that's actually pretty good when you think about all the things that are going on in the background, but it's not good enough for real high-end gaming. GeForce Grid solves this, and GeForce Grid is the name we give to our cloud gaming structure. So now you can think of it as an entire grid of GeForce processing that's out there, and you can have that experience of high-performing, quick-reacting gaming anywhere, no matter where you are. This is the breakthrough of Kepler, and this is the exciting thing that we now bring to the market. And you can see that if you now stack up the lag, if Gaikai took our existing system, it would actually be slightly better than the reaction time of a game console. And yet it's sitting out there on the cloud somewhere, you don't even know where. And we demonstrated this at our GTC, GPU Technology Conference, as well as our Analyst Day, where we took a smart TV from LG, we took a Transformer Prime, which is a Tegra-based tablet, and we took a high-end PC, and we had some of the world's greatest gamers play a game, Hawken, which is a brand new game, which probably will be one of those several $100 million games, has realism that's amazing. which you could never have on a smart TV, you could never have on a tablet if it was running on the client. And those gamers played the game and had a great experience. The cloud ecosystem has several partners. There's the enterprise side and the cloud side. You can see the names of the participants in the ecosystem. A lot of important technology in the entire ecosystem. And the ecosystem is important because you're now tying together the cloud and the local client in a way that requires fine-tuned orchestration of the response times. And thus we achieved that vision that I talked about earlier, bringing the interactive graphics to the cloud. This is the last frontier of cloud computing. From here, it just gets more and more interesting, and we create a whole new world. And when you combine the optimizations that we're doing on Tegra for the client side of it with the optimizations that will continue to happen on the cloud side of it, you're going to see amazing things happen where you won't hardly carry anything. What you'll be carrying is so small, and yet you'll have such an advanced experience that it'll feel like it's just part of reality if it wants to be, or it can. One of the great things about 3D visualization is it can feel like reality at some times, and then it can feel fictional at other times, which is something we enjoy doing. Thank you for your time.
Thank you, Mr. Carmack, for sharing your ideas.